Let's delve deeper into Mars and why landing on it is so challenging. Mars exploration. The difficulty of landing Mars is often referred to as the next frontier for human space exploration due to its similarities to Earth, such as the length of a day, the presence of seasonal changes, and historical evidence that it may have once supported liquid water. However, landing on Mars is a significant technological challenge, and here's why. 1. Mars atmosphere. Thin and unpredictable Mars has a very thin atmosphere, which is about 100 times thinner than Earth's. This creates two primary challenges. Aerodynamic challenges for entry. On Earth, when a spacecraft re-enters the atmosphere, it slows down significantly due to air resistance. But Mars' thin atmosphere doesn't provide enough drag to slow down a spacecraft the way Earth's atmosphere does. This means that entry speeds have to be very carefully controlled to avoid either crashing into the surface or skipping off into space. Heat shielding. As a spacecraft enters Mars' atmosphere, friction causes it to heat up at extreme temperatures. The heat shield must be robust enough to withstand temperatures of up to 2000 degrees Fahrenheit, 1093 degrees Celsius, while also being light enough to allow the spacecraft to carry its payload, like a rover or scientific instruments. 2. The 7 minutes of terror. NASA has famously described the landing sequence on Mars as the 7 minutes of terror, due to the incredible challenges it faces during this short window of time. High-speed entry. A spacecraft traveling to Mars approaches at speeds of around 12,000 miles per hour, 19,000 kilometers per hour. As it enters the Martian atmosphere, it needs to decelerate rapidly from that speed to a safe landing velocity. The atmosphere is too thin to provide enough drag, so the spacecraft must rely on other methods. Parachutes aren't enough. During past missions, large parachutes were deployed to slow down the descent. However, due to Mars' thin atmosphere, parachutes don't work as effectively as they do on Earth. The parachute may only slow the craft by 70% or so, leaving much more to be done to slow it to a safe speed. Rocket landing systems. NASA has had to innovate and develop unique landing technologies, such as powered descent systems with rockets, to slow the spacecraft further. For example, in the case of Curiosity, 2012, NASA employed a system where rockets fired to further slow its descent, and a sky crane device lowered the rover to the surface once the spacecraft was close enough. Lack of real-time control. Unlike in Earth missions, communication between Earth and Mars has a delay due to the vast distance between the two planets. The signal takes between 13 and 24 minutes to travel one way, meaning that a spacecraft's landing on Mars must be fully autonomous. The ground controllers can't intervene in real time. 3. Mars terrain. A minefield of obstacles. Mars is a rocky, uneven world with craters, cliffs, sand dunes, and other obstacles. This makes selecting a safe landing site extremely difficult. Risk of damage. If the spacecraft lands in an area with sharp rocks or steep terrain, it could be damaged or destroyed upon landing. Past missions have been successful in landing in relatively flat areas, but finding a perfectly safe spot is far from guaranteed. Rover mobility. Once a rover lands, it has to navigate a treacherous landscape. The terrain is often rocky or uneven, making it hard for rovers to travel long distances without encountering obstacles. The rover's wheels and suspension systems must be specially designed to handle these challenges. 4. Asterisk examples of Mars landing failures. Asterisk Phobos Grunt, Russia, 2011. Asterisk asterisk. One of the most famous failed Mars missions was Russia's asterisk Phobos Grunt mission, which was supposed to return a sample from the Martian moon Phobos. The spacecraft failed to leave Earth's orbit, rendering it a failure. Asterisk Beagle 2, UK, 2003. Asterisk asterisk. The Beagle 2 asterisk mission was meant to land on Mars and search for signs of life. It was believed to have been a failure after communication was lost, but in 2015, scientists discovered that it had actually landed successfully, but its solar panels failed to deploy correctly. Asterisk NASA's Mars Exploration Program. Asterisk. Many of NASA's early Mars missions, such as asterisk Mars Polar Lander, 1999, and asterisk Mars Climate Orbiter, 1998, also ended in failure, often due to